All right, let's get started. Thanks for attending our webinar, Your Battery Questions Answered. This is a special topic joint webinar produced by BAE Battery, Solar Systems Services, and Morningstar. I'm Mark McHenry, Marketing Manager with Morningstar, and I'll be your moderator for today's session. And today's presenters are Steve Belisle, Applications Engineer at BAE Battery USA, and Rob Rollo, President of Solar Systems Services. Our three companies are independent, but we work together to provide solutions for your off-grid applications. So let's go ahead and take care of some housekeeping items before we start. If you go to the previous slide here, just want to let people know as you listen to the webinar, you can go ahead and feel free to type any questions that you have in the questions chat on your GoToWebinar console. I will address those questions at the end of the session. A copy of the slide deck that we're using today and some data sheets are included in the materials handout section of your GoToWebinar pane. So we recommend that you go ahead and download them right now. And we're going to be recording this broadcast, and we will email you a link to the recording before the end of day tomorrow. And with that said, let's go ahead and take a look at the agenda for today. We're going to start off with a brief introduction to today's presenters and the companies that we all represent. And then today's speakers will talk about the importance of focusing on the big picture, which relates to your goals and objectives concerning your off-grid applications. We'll address some common things that you've heard about batteries over the years that may or may not be entirely accurate. Our speakers will alert you to the fine print in data sheets and manuals that you'll need to be aware of so you can get the correct answers. After concluding the presentation, we'll take questions from you, the audience. So I'd like to tell you a little bit about Morningstar. So first and foremost, Morningstar is a U.S. company that conducts business through authorized distributors and dealers all over the world. Since 1993, we've been a leading supplier of solar charge controllers and off-grid inverters. We're considered to be the charging experts, and we've sold over 4 million controllers and inverters for all types of industrial, mobile, and residential off-grid applications. We've been rated as the best off-grid solutions provider in terms of product quality, tech support, and customer service by Global Solar Distributor Survey respondents for many years in a row now. Steve, we'll advance to the next slide and let you tell us a little about BAE Battery. Go ahead.
All right, well, I'm Steve Belisle, BAE Batteries USA. I'm just going to talk about the BAE product here real quick. To start us off, the BAE Batteries is a German company known for their quality and reliability in the market. They're big into quality assurance, so ISO is a big deal. All of the products by BAE are made in Berlin, Germany. Go to the next slide. So our core business is really the production of advanced lead-acid stationary batteries for critical applications. Some of our big markets are electric utility, UPS data centers, but we also play big globally in the renewable markets, recycling batteries, and have a long-standing tradition in that market globally. Next slide. So BAE Batteries USA, we're located up by Minneapolis-St. Paul, headquartered in Somerset, Wisconsin, which is just in western Wisconsin. And we're the support team for the BAE product in the US. Our team has an experience of over 150 years with our employees. We're an employee-owned company, and we work together to commit to providing excellence and good customer service to the US market. We're well known in the industries we play in and work with some of the largest companies in the world, especially in the electric utility market. Next slide. So from a renewable cycling standpoint, we have two different battery lines. It's a PVS line, which is a wet cell or VLA battery line, and a PVV product line. Both of them do really well in the cycling market. The PVV line is probably the more common for the cycling market due to its lower maintenance, but both of them excel in cycling applications, and we'll spend some time talking about that here this afternoon. Next slide. One big thing with our PVV line is we're the first lead acid battery to be UL 1973 listed with the UL 9540A test, and that was big for BAE in the US market with the changes in the codes. Um, it's a proven technology, safe and reliable, and we're going to spend a fair amount of time talking about that in the coming slides. One of the other big things we've recently come to market with is what we're calling the Oxbox. So this is a lead acid battery storage solution predominantly for the residential market, and it is a UL listed 9540 storage option. It uses the BAE PVV cells, and its full rating is 40 kilowatt hours in one box of batteries. So it's a robust, safe, reliable solution uh, that works with many different um, inverter options. And with that, we'll turn it over to Rob.
Thanks, Steve and Mark. Let me introduce myself briefly. My name is Rob Rallo. I am President and CEO of Solar System Services. I have over 35 plus years of experience in solar power systems, design, engineering, documenting, training, things like that. System types are grid connected, primarily with battery backup, off-grid of all types, hybrid, UPS systems. And again, any type of power solution that is using batteries that I've probably been involved in. And most of the small scale though, generally anything from a couple of watts up to a couple hundred kilowatts. Nothing in the megawatt range though. I'm an active member of IEEE Standards Association as well as being involved in several of the codes organizations. So I'm pretty up to date with all the latest requirements and what's coming out pretty soon actually. New requirements coming out for 2026. So that's all for myself. Let's answer your question. So everybody's here to get their battery questions answered, and sadly, the answer is going to be it depends. The answer is always going to be it depends. It depends on the battery technology and the manufacturer. It may also depend on where the battery is installed, as temperature can make a difference. The jurisdiction which you're installed in might make a difference, and that might be whether you can sell, if you're grid connected, whether you can sell back or not. Or whether you need to have fire suppression equipment in some areas, et cetera, et cetera. The application is going to make a difference. Again, whether you're on grid or off grid, or whether you're cycling heavily or not. So all these things that go into, um, you know, the answer to your question as to how your battery is going to perform, what the settings are, what battery you should use, et cetera, et cetera, et cetera. So again, there's many variables that go into the performance of the battery, and we're going to, since we're not going to be able to answer all of your questions directly, because again, there are so many variables that go in that we just don't have time. We want to, in this webinar, we want you to think about the things you need to think about. So we're going to try to bring up some of these things and make you aware of them, and then we're also going to try to show you where you can find the answers to some of these things that you can try to answer your own questions. And again, the reason for that is that one size does not fit all. So a battery that might work great for one application or one regional location may not be appropriate in another. What might work in a cold climate may not work in a hot climate, and vice versa. What might work in a UPS application may not work for an off-grid cycling application. So again, one size does not fit all. We're going to try to help you figure out what might work best for your applications and what might work best in your circumstances. Okay, so that brings me to the big picture. And the big picture really is, what is the goal? What is your application? What are you trying to achieve? Because again, one size does not fit all. So what is the right product for your application? And again, the product might not be a battery. It could be energy storage. So let's start by, again, addressing this big picture. Again, I'm pretty much just a consultant that does systems designs for various organizations. And generally, when I start off, I just have to ask a whole bunch of questions. And the big thing is, what are they trying to achieve? What's the goal? What are you trying to do? And the answer to this question drives the design and therefore the required components of the system. As an example, if you have a residential customer who's just trying to reduce their electric bill, do they even need a battery at all? I mean, if they can sell back to the grid, why bother adding money for a battery? But if they're not allowed to sell back to the grid and they're looking to use that battery repeatedly, then that might be different than, hey, we're just trying to do backup for a couple times a year to lose power, because again, that application is slightly different, so the battery use might be slightly different. So all these things make a difference as to what the correct product for the market is. And I'll give you another example when it comes to water pumping. Again, you're looking for energy storage. You store the energy in a pumped water tank, not in a battery at all. So sometimes the answer to that question isn't even a battery. Again, you're looking at energy storage. Um, and there are other energy storage models as well. There's flywheels. And again, we're not going to get into all those things. The idea is for you just to think about some of these things and look at the options yourself. Do your own research. That's the most important thing. If you contact a flywheel manufacturer, they're always going to tell you their product is the best, and they're going to always sell you that. That's what they're trying to do. So it's best to kind of do your own research and look around and see if that product really meets with your application. And again, different products work for different applications. When all you have is a hammer, everything's a nail, but sometimes what you really might need is a screwdriver for a screw. Just keep that in mind. And again, so as we go through this webinar, we're going to go through various examples that are going to try to help you to look at some of these things. I encourage you to do your own research. And again, we're going to try to talk about, we're going to be careful with generalizations because again, there's examples for and against everything. So we're going to try to, I guess, in a lot of cases, we're going to prove and disprove a lot of things you may think about batteries. So we're going to try to give examples of both of those in most of these cases. So again, always be careful about making generalizations about that. And again, read the fine print. I'm going to point out a couple examples of looking at data sheet that had a little blurb, and you have to go look at the asterisk or note one, and note one says something that's pretty important. So it's always important to look at those notes and those fine prints and things like that. Again, so generally the manuals and the spec sheets have most of the information you need in it. Some of those actually have grandiose statements in them, so be careful of that. Look at the data itself. The data is the most important thing, and make certain the data is coming from some type of reliable test source. As an example, when it comes to battery cycle life, it should be tested to IEC 61427 or 60896, or domestically it might be a BCIS-06. So again, I'm just rambling off specifications, but it's okay. At least they should reference a specification as to how that battery was tested, so that you know that that cycle life wasn't just something they made up, but that it was through an actual standardized test that confirmed that battery cycle life. And again, that's just one example of many when it comes to these things. Okay, so let's move on to our first question. And the first question is, okay, can you discharge lead acid battery past 50%? I hear this a lot from people. And so Mark's going to go ahead and launch the first poll, and we're going to ask you, the audience, to answer this question. Do you think you can how far do you think you can discharge lead acid battery? And I think that's probably good enough. It looks like most people have responded. Okay. Let's go ahead and end the poll and post results. Okay. So majority of the people, about almost 40%, think you can discharge a lead acid battery to 80%. And the answer is yes. And actually, you can even go further sometimes. And I'll let Steve address that in just a second. But yeah, you can absolutely use 80%, no problem. I've been in the solar industry for over 35 years, always use 80%. And as a matter of fact, this is the LVD set point used by most controller manufacturers. Go to Morningstar, most of theirs are set to about 80%. I just bring that up because I hear lots of times from people who don't know any better that they keep hearing you can't discharge a lead acid battery past 50%. Okay. Now, the answer is that the other thing is this is also kind of a depends thing. Yes, you can, but the other thing is that do you want to discharge your battery 80% every day, or how often you want to do that? And we're going to get into some graphs on that, because the further you discharge lead acid battery, uh, the more you're going to shorten its life. There are only a lead acid battery only has so many cycles, and the more deeply you cycle it, the shorter the lifespan. So I'm going to give you a few examples of that. So as an example, here is this is a 12-volt AGM battery, and you can see that you can only discharge it about 325 times at 70% DoD. That's not much. So if you're cycling that thing every day, that's 1 year and that battery's done. There's another one as well from the same manufacturer, but it's their 6-volt battery, and it can cycle up to 550 times to 75% DoD, which is still not great if you're cycling it every day to that far, because that means you're only going to have about 2 years or less on that battery. Now, on the other hand, if you go to, say, 50% DoD on those batteries, again, now you're up to like 600 cycles, and on the one, and up to 1,000 on the other. So you've about doubled the cycle life just moving from 75% to 100%, and yet you're doubling it again, going up to 25% or even more on the case of the little 6-volt guy. There are 2,400 cycles. I mean, at 2,400 cycles now, you're looking at about 10 years, or pushing 10 years. You're looking at about 8 years or so. I mean, you're really up there. It's at the point at which the battery will most likely fail for some other reason at that point over cycle life. Okay, and by the way, note, this is a mediocre battery. This is just an average battery. This is not a special one. This is just kind of an average one. There are also advanced technology batteries out there now, newer ones. This is the BAE battery. It's a tubular plate one. This is their tubular plate gel, the PVV. And you'll note that this battery can cycle 1,500 times to 80% DoD. Okay, that's just 80%, almost 1,500, which is quite substantial. And now, if you look at it around the 15% range, you're looking at over 10,000 cycles. So again, so yes, you can discharge it to 80% depending upon the better technology in the manufacturer. I mean, 1,500 cycles is a lot. That's about 3 years of discharging it, or more, of discharging it deeply every day. But even then, again, if you just go to the 50% range or further, you're looking at a battery that you can get 10 years or more out of just by not cycling it that deeply.
One thing
But
I did want to bring up, Rob, if you
yeah,
go
thanks,
back
Steve,
one
jumping
slide,
here.
and this is something Rob and I had talked about prior to the webinar, is you'll notice the graph stops at 80%. An important point I want to make to everyone is that when you're looking at a quality lead acid battery like the BAE, our data sheet ratings are all based on that 80% DoD. So in many cases, from a layman perspective, if it's on the data sheet, that's your amount of capacity you can use out of the battery. Now, from a technical standpoint, that's 80% of your capacity. But I just want to be clear that that doesn't mean you look at the data sheet and then you can only use 80% of that rated capacity. What's on the data sheet is actually the usable capacity of the battery. Um, you know, it's questionable that any battery can be used at 100%, because if you think about it, at 100%, you're going to have voltage collapse of your DC system, whether it's a lead acid battery or something else. So I just wanted to point that out so that people understand when they're looking at rating sheets, data sheets for products. If it's a reputable manufacturer like BAE, the data we're giving you is the usable capacity.
Thanks, Steve. And to that
Go ahead.
point, a lot of the lithium battery manufacturers will actually put two different capacities on their data sheet. They'll put one capacity, then they'll say usable capacity. So they do it that way on some of the lithiums. And the other thing, to your point, this is true. It's almost impossible to use 100% of any battery, as the voltage will collapse to the point at which your load would no longer function. There's some point at which your inverter is going to drop out, or whatever your load is, even a lighting load. At some point, it's going to not have the voltage for it to operate anymore, and it will stop long before you get to the end of discharge of your battery. So thanks for pointing out. That's a good point. I also want to point out, speaking of lithium batteries have the same problem. As you can see here, here's a lithium battery where at 50% discharge, they're getting around 13,000 cycles. They're only getting 7,000 at 80% discharge, and they are saying it can discharge this thing to 100% and getting around 3,500 cycles. But again, I question that as well, because at 100%, I don't think your load's going to function anymore. So again, what I'm trying to say is that the cycle life versus discharge is appropriate to all batteries, not just lead acids, by the way. Okay, but and I start out by talking about depth of discharge, because this brings up my second question. Do you need to cycle the 80% depth of discharge every day? Um, and again, if you're looking at a UPS system, you may only use it 5 times a year. If you're looking at a standalone PV system, I don't think you want to do that, because if you have a cloud pass over the next day, you're not going to have any batteries the next day. Hybrid systems are a whole other thing, and there are other systems, again, where you have to look at it. Do I really need that kind of depth of discharge? There are examples where you might. If you're looking at peak load shaving or something like that, if you're grid connected, then yeah. Then if you're grid connected, that might be the case. But if you're an off-grid system, um, it might not. So again, this goes back to the original thing I was saying about the big picture. What's your goal? What are you trying to do here? What's the application? So all those things matter. Mark, can you launch the next poll, which is basically how far do you need to discharge your battery on a daily basis in your applications and in your projects? Okay, I think we're about to slow down. Let's go ahead and let's go ahead and post that and then move on. So it looks like about 20% of people are only doing backup only. And again, you can have a battery that cycles 10,000 times, but if you're only using it a couple times a year, then who cares? Type of thing. So again, getting a expensive high cycling battery may not be necessary when all you need is something that can just do the job, a few times a year, type of thing. It looks like the majority of the people, over 40%, are only cycling that battery 20%. And very few, only 12%, are cycling 80% every day. And I'm going to go into, I'm going to continue this by talking about solar, because I know a lot of people on here are going to be talking about solar. It's That's what most of us are here for anyway. And again, when you talk about solar applications, there's a rule of thumb out there. There's actually not a rule of thumb really. There is a design guide by IEEE. It's IEEE 1562. And that design guide states that you should have a minimum of 5 days of autonomy for a standalone PV system. Again, it's their standalone PV. So they're saying you should have a minimum of a 5-day autonomy. A lot of people say you can get away with less. And again, the autonomy, though, a lot of people think it's for the health of the battery. It's not for the life of the battery. It's about the availability of the system. That specification was written with reliability of the system in mind, not the battery. And I'm going to probably do a white paper on this at some point, because I get asked this a lot, and I've been showing these graphs a few times now, but I'm going to just briefly kind of go through why that's the case. So I crunched some numbers and I did a probability analysis for a 100-watt system that's 12 volts in Kansas City. Okay, and it's using a solar array of about 1.2. So that means the solar array is oversized by about 20%. Okay, and for a 1-day battery, you're going to have your system's going to fail you're going to have 20 incidences, or 20% of the time failures in December. You're going to have more in November. At the end of the day, basically, your system's going to have a lot of problems for most of the year. The only time there are going to be issues is going to be in the summertime. So 1 day doesn't really work for any PV system for the most part. Even 2 days is pretty atrocious, as you can see. When you're looking at 10% of the time it's failing in December, 5% of the time in November. I mean, I wouldn't even do this with a lighting system. Now, at 3 days, you're approaching something that might actually be workable. I mean, you're looking at about 4% of the time failing in December and about 2% in November. For a lighting system or non-critical load, this might actually be okay. I mean, if you're like something where you're okay, yeah, I don't mind if it fails a couple of days in December, this 3 days might work for you. Okay, but again, I would never do anything less than 3 days. And again, this is only, hey, if it goes down, I'm okay with that type of thing. Then let's move on to 4 days, and you can see, geez, now we're down to only about 2% of the time in December and less than 1% of the time in November we're looking at failures. And then finally, if we go to 5-day, which is what the standard recommends, you're now then less than 1% failure in December, about 0.3 in November, and negligible in January. So at this point now, you're looking at a failure about once every 3 years. So this is what we refer to as availability at 99.9%. So basically now the system has available 99.9%. For most people, this is plenty good enough. However, there are some industries like the railroad and oil and gas that need even better than that. They need 99.99% availability. In those cases, they use a 7-day and an 8-day battery, which is what IEEE 1562 also recommends. It has in there for critical loads, they do recommend the 7-day batteries a minimum. Okay, so what does this really mean though? Well, again, if we're looking at a battery of between 3 and 5 days, well, if you're using 5 days anyway, you're only discharging your battery at 20% on a daily basis on average anyway. So again, I look at it as, if you have a battery that can cycle regularly at 20%, that's probably fine. Even if you're going to go to a 3-day battery, you're only doing 33% depth of discharge on a daily basis. You're not even approaching 50%, which would be for 2-day autonomy. So again, it comes back to, do you really need that or not type of thing. So again, having a good quality cycling battery to, 20 or 30% is probably all you need for an off-grid PV system. And if you can get, a lot of cycles to there, that battery, and you take good care of that battery, you charge it correctly, you can maybe get 10 years out of that battery or more. So let's look at another thing to talk about, climate. Climate can matter quite a bit, hot temperatures and cold temperatures. And we hear a lot about lithium batteries and cold temperatures. And so I'm going to poll the audience again right now, to see whether you think you can use lithium batteries in cold climates. Okay, I think it's good enough. Thanks, Mark. Okay, let's post that. Most people think you can. Well, this is one of those where you really need to read the fine print because you sort of can, you sort of can't. Okay, this is where it gets tricky. Here we go. This is where it gets tricky. So you can discharge a lithium battery pretty far. Okay, so here's a spec sheet where they said the operating range was from minus 20 Celsius, minus 4 Fahrenheit, to 135. That'd be 57.2 Celsius. Okay, but here's where it gets kind of tricky. There are caveats about low temperature charging. Okay, so the BMS will not allow charging below 25 Fahrenheit. That's minus 3.9 Celsius right now. So basically, it's not going to allow charging underneath 25 Fahrenheit. Well, right now, there's been just cold snap after cold snap after cold snap across the United States where you're definitely under 25 Fahrenheit most of the day. So that would mean that you can't charge this battery. Now, it might discharge. So, hey, if you're using a UPS application, that's fine. It'll work there, but you're not going to get a recharge until it warms up. And that could be a few weeks at this point before it warms up where you can reuse your battery again. So again, read the fine print, look at the manual, look for other information on that. It can operate, but that's only discharge, that's not recharge. And this is not uncommon. If you give you another example one, and by the way, this is a lithium iron phosphate battery, which is the one most commonly used. Most of the stuff I'm going to be mentioning about the lithium batteries, we've rated the lithium iron phosphate, LFP, because that is the more commonly used lithium batteries for solar applications, because that's the one that does better with cycling and these types of use cases and cycling applications. Okay, here's another example. Again, this spec sheet actually says that, again, you can discharge to -4 Fahrenheit and you can charge at -4 Fahrenheit. But they have a little asterisk there, and this is for charge currents below. There's an asterisk with charge currents below freezing, basically. But they don't give anything else in the spec sheet. So you actually have to go to the manual to find more information. When you go to the manual, it says, okay, you have to reduce your charge rate. Okay, which means and this could be a problem. Again, if you're trying to charge your battery quickly with the limited solar you've got, and now you're limited to using a small portion of solar array, you may not get that battery fully charged in a timely manner. And that's at the 10%. This is a 0.05 C or 5% of the battery capacity rate, which is even worse. That's below 14 Fahrenheit. So again, look at the notes, read the manual, look at the fine print, because again, this stuff wasn't obvious. They didn't tell you back here on the spec sheet. They put a little asterisk, and they don't say anything else further. You have to go to the manual to figure this stuff out. Okay. Yeah. Okay. So, give another example. There's just another example of that one as well. This is a spec sheet where they're actually pretty upfront about it. Also about operating temperature, and then they kind of giving you two things. And then it says you actually have to look at the warranty for other information. So it gets a little tricky on that one. So again, they actually give you a charge temperature that is more in line with the operating temperature. So at least this manufacturer is pretty open and upfront about it. Now, some of the manufacturers for lithium lead batteries have found a way around this. They've added heating elements to their batteries. Okay, but again, if you're on a solar application, you have a limited resource. Now, so where's that energy coming from to heat that battery? Well, depends on the battery and the manufacturer. Some of them are using the battery itself to heat itself, and some are using the solar array. So again, this is an example of one that actually uses the solar array, but that says you need 1 hour. This is for a 100 amp hour battery, by the way. Most of these are for 100 amp hour 12 volt battery, standard group 27, group 30 batteries. So again, it's using 1 hour, 10 amps to heat the battery up before you can start charging the battery. Well, if I'm only getting 3 or 4 good sun hours a day to of solar, and I'm wasting an hour down on the battery, I now need to oversize my solar array by at least 20% or more now to compensate for this. And again, you have to take this into design considerations now. So it's not that you can't use it, it's just now you have to oversize a solar array to make sure you have enough to heat the battery up so it can actually be charged. Okay. Other ones, here's another manufacturer that said that has the same information, but then it gave me nothing on what the integrated self-heating is. So I have no idea how much energy it's even consuming. So I don't even know how to oversize my solar array. So that's a problem. So now I don't even know what to design for because the manufacturer didn't give me any information on that. So again, so you have to go back to manufacturer, ask for more information, try to figure out how you need to compensate for that with the solar array or some other way. So just things to consider. So let's move on to the next question. Do lithium batteries lose capacity in cold temperatures? I think we have a polling question for this one too. Yeah, it looks like, okay, I think it's good enough, Mark. Thank you. Let's go ahead and post that. Okay, so it looks like most people, 75% or so, 3/4 of people think that, yeah, they do. And that is absolutely correct. They do. Just like lead acid batteries, they do lose capacity in cold temperatures. A lot of people think they don't. And so they're using it and not derating the battery for the cold climate. Again, same issue with lead acid battery. They're the same problem. I'm going to show you a couple of graphs that show that. And what I find interesting is that depending upon the battery, the D-rate charts aren't all that different than a lead acid battery. You'll see this one here loses 80% of the freezing. And again, that's about the same for a lead acid, somewhere in that ballpark. So that's not uncommon. I'm just going to skip down one real fast. This one's not all that different either. Again, it's about the same. So they're not. Again, each battery is a little different. That's the thing. I said that earlier. Each manufacturer, each battery is a little bit different. So make certain that you check their charts, because what might be true for one battery may not be true for another. Okay. And again, just for reference, this is the equivalent for an AGM battery, standard AGM lead acid battery. And again, you can see it's about 80% at around freezing. So it's about the same as the lithium. So okay. Moving right along. Next question. Are lithium batteries smaller than lead acid batteries? A lot of people think they are smaller. Oh,
Hey,
sorry,
Rob,
Steve, want to chime in there? Yeah.
I just want to chime in one thing on the last two questions, and I think most people know this, but, one of the benefits of, considering a lead acid solution is although you have capacity loss at temperature, just like a lithium, any chemical reaction is going to have that, you're not going to run into the issues of charging or discharging limitations on a lead acid battery. Without a BMS or anything that involved, they just work. They might work at a reduced capacity, but even getting down to extreme temperatures like where we are right now in the Minneapolis area, your lead acid battery is still going to charge and discharge even in these super cold weather. Uh, it's just going to have some reductions in capacity that you got to take into account. So I think most people realize that, but I do just want to point that out.
No, thank you, Steve. Yeah, I did not mention that earlier. I probably should have that those temperature charging issues do not affect lead acid batteries. Doesn't matter what the lead acid technology is, whether it's a wet flooded battery or whether it's a valve regulated battery, AGM or gel, doesn't affect that. It's still going to charge in the colder temperatures without an issue. Thanks for reminding me of that, to point that out. Thank you. Okay, let's go ahead then, and Mark, you want to go ahead and post that next question? Yeah, I think it's pretty much stabilized now. Okay, so let's go ahead and post that one. So it looks about 70% of the people think that a lithium battery is smaller than a lead acid battery. And the answer to that is it depends. Uh, the majority of the lithium iron phosphate LFPs actually are not. They're about the same size as lead acid. I'm going to give you a few examples of that. Again, there are examples of ones that are not, that are smaller. There are manufacturers that do make them smaller, but again, in a lot of cases, they are about the same size. So, let's see. So if we're going to go back, let's go back to our presentation then. And here's a manufacturer that has a statement that I find interesting in their spec sheet, saying that it's a 12 volt, 100 amp hour battery. Again, lithium iron phosphate, so it's an LFP, that is 2 to 3 times the power and the same physical shape as a lead acid battery. Okay, but when you dig deeper and you look at the spec sheet, you go, oh, it's 12.76 inches, basically 12.75 inches, by a little less than 7 inches, by a little more than 9 inches. If you look at that, you realize that's the size, standard size for a standard Group 27 or Group 30 battery. So that is, again, 100 amp hours in a 12 volt battery. That's a standard Group 27. That's exactly the same as lead acid. Exactly the same. So that's not any smaller. It's exactly the same. So here's another example of another lithium iron phosphate battery. Exactly the same thing. 13 inches by 6.7 by about, again, a little less than 9. Again, it's the same dimensions as a Group 30. And it's also about 100 amp hours. Again, 100 amp hours and 12 volts. So again, another example, and I can give you ones of an 8D battery as well, or a 4D battery, or again, so a lot of the lithium iron phosphates have exactly the same capacity as a lead acid battery and exactly the same size. So are they smaller? No. in a lot of cases are exactly the same. Now, again, you're going to probably find, I could probably ramble off and find some other examples of ones that are not, that are smaller. This is true. But, just be careful. Don't take, again, in not all cases are they. There are a lot of cases where they are exactly the same. And again, there are some where they are smaller. And I think I got one more example of that as well. Here's a GC2, kind of the same thing, and it's got the same size as well. So it uses prismatic cells instead for the lithium iron phosphate. But it's the same thing. We'll see the exception. Again, the lithium iron phosphate actually really ends up being about the same size as lead acid in most cases. There are other lithium technologies out there, lithium, magnesium, cobalt, some other ones that are smaller. They have a higher energy density. So again, I'm not going to say this is true for all lithiums, and I'm not going to say it's true for all lithium iron phosphates, but a majority of them, a lot of them, are at about the same size and package as the lead acid with exactly the same capacity. So no, they're not. They're about the same. Which brings me to the second point, though. Okay, are they lighter then? Are they lighter than a lead acid battery? And I think, yep, we do have a question for that one too. That's probably good enough. Let's go ahead and post that. So it looks like the majority of the people, 85%, 86% of people said they are lighter. And let's go ahead and close that poll. Go back to presentation. Yeah, that's true. That is true. I checked a whole bunch of Group 31 lithium batteries, and the majority of them weighed anywhere between 28 and 31 pounds, whereas the equivalent of valve-regulated lead acid battery, a Group 31 battery, basically weighs about 60, 70 pounds. About double or 2.5 times heavier for a lead acid than a lithium. So yes, they're lighter, and absolutely, and there's great places for that. I mean, if you're in a mobile application where you need lightweight, it makes sense to use a battery like that. Again, if you're in a marine or RV or something like that, great application for using those if temperature isn't an issue because you got weight on the axle or something like that. But again, I want to get back to what I said earlier about some manufacturers making grandiose statements. That one that said that they had 2 to 3 times the power, as you can tell from what I showed earlier, it was exactly the same. Also made a statement that there was 5 times was so much lighter. Was 5 times faster. They can be charged, and it was also lighter. They're one-fifth. They are one-fifth the weight of a comparable lead acid battery, and as you can tell by what I just said, no, it's not. It's about half. It wasn't even close to one-fifth. It was about half. So again, double check some of their statements, especially grandiose ones. So that's all I'm saying. On anybody's spec sheet, they should be, again, referencing standard tests and stuff like that. When it comes to their cycle life and other things, there should be a way to confirm their information. Okay, they also made a statement about faster recharge as well. And so I'm going to throw another question. Do lithium batteries have a higher recharge rate than lead acid batteries? And what I mean by that is, can you charge them in less than an hour? That's probably enough. That one looks like it's split 50-50. That's split 50-50. Okay, let's go back to the presentation. And the answer is it depends. There are lead acid batteries like the BAE battery that can be charged in less than an hour. They can charge 1 hour rate. And actually, believe it or not, there are some lithium batteries that actually cannot because they overheat too fast. Most lead acid batteries, though, in general, can be charged in the 3-hour rate. But I also get back to my question of the big picture. Do you need to charge in 1 hour? Almost can't think of any application where you need to charge any battery in an hour and 1 hour. And a UPS application, generally you want to recharge in 12 to 24. Now recharging in 1. And most solar applications, nobody's oversizing the solar array that much because why would you want to recharge your battery in 1 hour with solar? Usually you want to take the whole day. So now you're looking at a 4-hour recharge rate or 5 hours, something like that, or longer. You're generally not oversizing your array that much. So again, it comes back to, it depends because it depends on the battery. It also comes back to the application. What are you trying to do? Do you need that? Does it matter? And a lot of these things, it's like, a lot of these batteries have features that you may not need for your application. So it's, again, it gets back to, thinking about what is appropriate for your application in a lot of cases. So, and this is one I heard this. I heard this a long time ago from somebody, and I always find this fascinating. I've heard people say they think that AGM batteries are better than gel. So let's go ahead. I want to see what the audience thinks about that. And I think the audience is paying attention because most people are saying it depends. Yeah, I think it's good enough. Okay, let's go ahead and post that and go back to presentation. Yeah, it does depend. That's absolutely correct. And I thought it was interesting because I had a client tell me that they insisted that they had to have an AGM battery because it's better than a gel. And I asked him who said that, and it turns out it was an AGM manufacturer. And I showed him these two graphs. These are two different spec sheets from the exact same manufacturer. It's a manufacturer that makes both an AGM battery and a gel battery. The graph on the left is their gel battery, which shows a cycle life of around a cycle life of around 1,000 cycles to 50% DoD, and their AGM battery, which shows 500 cycles to 50% DoD. So the AGM battery had half the cycle life of their gel. So he goes, oh yeah, well I guess their gel is better than AGM. I go, yeah, it depends. I mean, again, it depends on the manufacturer. And as I mentioned earlier, I mean, if this was a BE gel battery, you'd be looking at a cycle life of 2,800 cycles, which is even better. So again, it really truly depends upon the manufacturer, not even the technology, because even amongst AGM batteries and gel batteries, there are manufacturers that use different different types of additives and electrolyte and plates and stuff like that. Different ways to be able to improve their battery performance. The plate design can make a huge difference, whether you're using a tubular plate or a flat plate. The thickness of those plates. Again, some batteries are designed for car charging, and their plates are thinner because they need to deliver energy faster, and other ones have thicker plates, which are better for cycling. So again, there are so many variables that can go into how a battery is made and what the battery is for, which is why it's so important to use, again, the right battery for your application. Okay, so and again, I think everybody was paying attention because I think you got the point about it depends. Again, the whole point here is not all batteries are created equal. You know, it really depends what you're trying to do. It depends on where you're going to install it. Again, temperature has a big effect on it. Your application, whether you're on grid or off grid, whether you're standalone, whether you have a generator recharge your battery, et cetera, et cetera. And don't believe everything you hear. Don't even believe everything you read on a spec sheet. Look at the data, read the manual, look at the fine print. And again, at the end of the day, select the best battery for application. And again, there's a lot of stuff we could have covered too. I did not even get into charging parameters. That's so important too. How you charge a battery in a UPS application is different than a hybrids application, and different than say a solar application. So again, there are differences there too. Um, so again, there are just so many variables that go into things that you can't answer them all. But again, if you talk to the manufacturer of that battery, they're going to have specific charging parameters for that battery for those applications. They're going to say, hey, for float charge, use this. For a cycling application, use that. And hopefully that information's in their manual. If it is not, contact that manufacturer and get it from them. Morningstar works with a lot of battery manufacturers already and already has all that information for you. They even have configuration files available for most of their charge controllers. You can just download and program their controllers with that information. BAE is also a battery partner with Morningstar now as well. So all of their information is up on I'm hoping by now we've got that up on the website along with those configuration files. If they're not, they'll be up there very soon. So again, I hope this was informative for you all. I hope it was kind of enlightening, and I hope at the end of the day we made you think about the things you should be thinking about. Maybe even a lot of things we didn't even mention here. Again, just things you may even think about that we didn't even address, because again, there's so many variables and so many things going on that you really do need to consider it all in order to choose the right product for your application. So thank you all, and with that being said, I think we're going to go ahead and jump into some questions here.
Okay, great.
I
Hey,
want
great presentation, guys. Did you need to say something, Steve?
Yeah, just I don't want to bring up two other points that Rob and I had talked about a little bit before too, but just two other things to consider when looking at batteries is one, don't always just consider the cycle life, just also you need to consider the actual overall life of the product. So you take like the BAE PVV product or OPTS product, this is a stable technology. It's well known for having a 20-year life plus life in real application. We have, lots and lots of data on that shows it. So it is something you also got to consider whenever looking at batteries. Just because you get a bunch of cycle life, if the actual life of the product is going to be less than your cycle life, it's not doing you a whole lot of good. Uh, the other thing, and we're not going to get into it because it's a whole can of worms, but always also consider your code implications and insurance implications. So there's a lot of changes in the industry, and Bob, Ken, and myself work in this arena a little bit for our respective companies in regards to codes. But it is something that any user's got to be aware of and just kind of have a pulse for what's going to be the easier solution in getting stuff through the code groups and the safer solution. So I just thought that was important to point out those two things.
Yeah, good point, Steve. Another consideration, and I kind of did mention that early on as well, that that can have an effect. And yeah, the new code is coming down the line. They're getting stricter on lithium batteries. They're now requiring fire suppression systems in a lot of locations, specifically sprinklers and other things, because of fire hazards associated with lithium batteries that lead acid batteries are exempt from. If they are UL 1973, of which the BAE batteries are, which is why you're going to see more and more lead acid batteries now being UL 1973 listed in 9540 with the 9540A report. BE was way ahead of everybody else. They've had their battery UL listed for over 2 years now. I think probably even 2.5 or 3 years now. So they got way ahead of the curve on everybody else. Again, because most of us are been involved in the codes, and we see this stuff coming, so we're trying to get ahead of it so we can have the best product for the market out there.
Great. Hey, we have some questions that came in from the audience. First question, actually, I received an email on this, I believe, yesterday, and he asked if we could address this. So the question is, how long can you store batteries before using them? I guess that would be best for Steve to address.
That's going to depend a little bit on the manufacturer, not even a little bit. So you're just going to have to look at the I&O manuals. Most lead acid batteries, or at least, are going to be somewhere between, anywhere as short as 3 months to as long as 12 months that they can sit in storage. Um, lithium may be longer than that. So it's just going to be important to look at the individual manufacturer's I&O manuals to determine how long you can store them and store them appropriately. I think that's really the biggest thing, is looking at that and making sure you're taking that into your considerations, or work with the manufacturer. You take us, we stock batteries, so we'd recommend not storing your batteries and only implement them as you need them.
All right, very good. So appreciate that answer. Question coming in from another Steve. It says, if a charge controller fails and allows a 12-volt battery to charge up to 14 volts multiple days, will this have a detrimental effect on the battery life and function? So I guess that's a question for either Rob or Steve.
Let's take it
Well,
with Steve.
overcharging, yeah, I can take it. So, I mean, overcharging your battery is always going to be detrimental uh, to its health. It depends on what you're being by multiple days and how often it's happened. What I'll say is, at least the BA gel tubular plate's a pretty robust product. You're definitely going to affect it. Uh, but, it's really going to come down to how long that's occurred for. Uh, but 14 volts also isn't that all. It depends on if it's just 14 volts, because that's about our equalized voltage. So it's not going to be super detrimental to it. Uh, but it also comes down to how often you're doing that and for how long.
Okay, very good. Let's see. Question coming in here from Rudolph asks, what is your opinion of sodium batteries?
Ooh, that's a good question. technology's still new out there. I have high hopes for it, and again, there's different variations on those as well. There's a couple of variations in the sodium, everything from lithium sodium to sodium ion. So there are a few variations. I don't really have one yet. I think it's still too early to tell on that one. I don't know if Steve has an opinion or not.
Well, it's kind of like everything else Rob talked about in his presentation. You're going to have to look into the details. You know, there's a few different options in sodium. Some of them are high temperature sodium. Now, using those in off-grid applications might be rather difficult because it's a high energy impact. You got to heat the battery continuously to make it work. So it's going to depend on the flavor and making sure you understand the full details of the battery.
All right, very good. And a question coming in from David. He asks, could you tell us a little bit about your opinions about solid state lithium batteries?
I had high hopes for that, but I've talked to some manufacturers that are working on it, and I I thought from a safety perspective it'd be better, but I've heard that they may or may not. I don't know. Again, I think there's still a lot of data out on that. I think it's going to depend on the manufacturer. At the end of the day, though, it may not be. It may have some advantages over existing lithium technologies, but they may not be as great as the hopes that they would have been. So again, the research and data is still out on that. They're still doing a lot of research. So I don't really know yet. It's still too early to tell. Kind of like the sodium batteries. Some of this stuff is just still too early to tell. And if you're an early adopter of these things, just be aware of the fact that you're an early adopter, and there's still a lot to be learned about them. That's one nice thing about acid batteries. They've been around for over a century now, and the performance on it is pretty well known. With some of these newer technologies, they have been out that long. So that we don't really know how they're going to perform long term in a lot of ways. So you end up being a guinea pig in some cases or a beta tester. And if you're okay with that, then that's fine. But just keep in mind that you're going to be a beta tester in some of these situations.
All right, very good. I see a question here that asks, let's see, they state lithium battery could be taken as alternative to lead acid battery. Can we take capacitor battery as alternative to lithium battery?
Ooh, that's new technology again. Geez, I wish I had Curtis with us right now, Steve. Curtis knows most of this stuff more than we do.
So yeah. Uh, so capacitors, again, they're very similar to batteries, but for the most part, my understanding is capacitors are mainly going to be suited for high power applications. They're not really going to work very well for any kind of long duration uh, energy support. At least that's historically, like Rob says, as stuff's changing so much, especially in the battery industry and energy storage industry. But historically speaking, capacitors are mainly designed for a very short duration discharge.
All right, very good. I see a question coming in for Steve. Question asks, what is the largest aux box capacity and how many can be hooked in parallel?
That's a good question. So the largest battery, the PVV that'll go in the aux box, equates to 40 kilowatt hours, and you can do up to four of those in parallel following the latest codes. Uh, Technically, you can do more than that, but from a code perspective, if you're complying with 855, four of them is the maximum.
That'd be
All right.
160 kilowatt hours, and
Hmm.
for those of you who follow kind of kilowatt hours, the average home in the U.S. consumes between 30 and 50 kilowatt hours a day. So if you got a 40 kilowatt hour battery, you're pretty much got about 1 day backup for your average house without making major modifications. Again, that's the average house.
Yeah, and
All
that would
right.
be based on supporting the full load of the house, correct, Rob?
Yep, correct.
See a question from Patrick. Let's see. He states, I have selected charge level that is approximately 87% voltage of max. Does this extend the battery life?
Ooh, For lithium battery, it depends on, again, that battery. Some batteries like deficit charging. For a lead acid battery, absolutely not. They like to get fully charged on a regular basis. But again, for lithium, you might be okay. It depends on that battery. Matter of fact, a lot of lithiums don't like to be fully charged on a regular basis. So again, it depends on that battery and the technology.
All right, very good. Let's see, I don't think I asked this question. Apologize if I did. What do we know about lithium graphite batteries? I know we had some people ask about sodium, but I don't think I asked this question. So, any thoughts on that? Lithium graphite batteries?
No, that's the first time I brought that one up. Again, it's a newer technology. Um, don't know much about that one yet, to be honest. Um, a lot of these are only being developed by one or two manufacturers, and the information on them is not really available yet because a lot of it's proprietary. So again, we have limited information on some of these at the time. So just don't know enough about that one yet. I don't know if Steve's heard anything different than I have on it yet.
I haven't heard about that one, but like Rob says, there's so much news in the battery world and changes. It's a question of how many of them will actually reach production and actually be something that's going to come out to the market. There's a lot of stuff being done at the university level that doesn't always actually end up into the real world.
All right, very good. I see a question here. Not sure if this is for Steve or for Rob, but they ask, can you explain thermal runaway in lithium ion batteries?
Ah. Yeah, and actually, by the way, just to bring that up, they've actually changed the terminology because of the thermal runaway in lithiums happens so quick within seconds. They've actually changed the terminology. It used to originally be used for valve regulated batteries. They now changed that term to thermal walkaway because literally, if you on a valve regulated battery, as somebody mentioned earlier, if you overcharge it, it will gas. Well, if you continue to overcharge a valve regulated battery, it will overheat, but the heating will stop once you take away the charge. They refer to it as thermal walkaway because it will walk away from the instant once the charge is removed. However, in a lithium battery, once you reach a certain point of no return, it really is a runaway and it will just ignite and go up. Um, this is the concern in the market. This is why the code keeps changing. This is why they keep putting more and more caveats into the code for it with regards to spacing and separation and testing and BMS controls and ventilation, all other kinds of things, is because of the fact that yes, the batteries can overheat. They're packing, in a lot of cases, they're packing a lot of density into a small space, and because of that, they have a tendency to overheat. So again, there are concerns that again you reach a certain point where it creates its own oxygen. So when that happens, it goes and it cannot be stopped at that point. I don't know if you want to add that on, Steve.
Yeah, I think you kind of hit on the big point, but with a lithium product, it depends on what you're dealing with. But the thermal runaway event is internally driven, so it doesn't require necessarily an external source, although it can be tied to that. But like Rob says, once it starts, you can't stop it. Uh, Whereas lead acid batteries is pretty well known. They don't go into thermal runaway from uh, what you look at from a lithium ion standpoint. They can only be driven into thermal runaway by a charging source. It's why the codes are much uh, more favorable to that style technology and becoming more so.
All right, very good. I see a question from Drew who asks, does battery self-heat while charging at low temperatures?
They generally do. It doesn't matter what the batteries, they generally do because again, batteries are 100% efficient, so they're going to some of that loss is in heat. So yeah, there's going to be some. Again, how much depends on the battery technology, manufacturer, et cetera, et cetera, et cetera. But yes, in general, there will be some self-heating of that battery when it's recharging.
All right, very good. And Richard asks, how can operating temperature range be wider than the storage temperature? He says usually products have wider storage temperature ranges than the operating temperature range.
It sounds. I don't know. You'd have to ask the battery manufacturer on that one. I do not know. But yeah, I agree with you. Generally, your storage temperature is going to be way bigger than your operating temperature. But I've seen lithium data sheets that say the opposite. I don't understand that one. I really don't. Yeah, so I don't know. I don't understand that one either.
All right. And I see a question here that says, let's see, what about using battery heaters in cold climate environments? What's your thoughts on that?
Uh, Again, that gets back to whether the heater is internal to the battery, whether it's external, whether using a diesel heater, a propane heater of some source, or some other type of heater. Again, it's just a waste of resource. It can be done. You absolutely can. People do it. I just look at though, if you're in an off-grid application, you already have a limited resource. So it's just something to consider. Now you're using additional resources because of that battery technology, and you have to ask yourself, what was the advantage of that technology? Was this the right application for it? Again, if you're wasting additional resources to heat it, you have to ask yourself, was that the right choice or not?
Okay. And a follow-up question here, will the BMS allow battery charging or battery heating below 25 degrees?
That depends on the BMS of that battery. Some will, some won't. Again, it depends on the manufacturer. Like I said
All
earlier, a
right.
lot of these are going to be it depends.
Yeah, a lot of good questions here. I think we covered most of them, but there's just a few more. I'm going to see if we can get them in here. Let's see. Let's see. Okay, is there a map showing the recommended days of autonomy for a critical load? Um, I would think they have an oil and gas flow computer application using solar power.
There's interesting. There are maps out there that actually BP Solar generated, I think 20 to 30, about 30 years ago now, by the way, that people use. And it's a solar installation map of the world, not just the country, but of the world. The problem is it's not of autonomy, that's of solar insulation. I would go back to IEEE 1562 again, which does recommend a 7-day or bigger or longer autonomy for critical loads. But the best way to really know for certain is you need to run a loss load probability analysis, like I had done in those graphs. So that's what you really need to do. It's really the only way to know for sure, because again, it's going to also depend upon the size of the solar array and and a whole bunch of other factors that are going into it too. Again, where you're located. Again, the solar resource. Yes, there's a lot of factors that go into it. So again, it makes it really kind of hard just to have a chart or a graph for that. It's going to be dependent on a few things. It's easier to run a probability analysis and get your exact answer.
Okay, very good. And here's a question they ask, is load shedding and solar availability counted in the autonomy?
Well, what ends up happening is that you would end up shedding the load. So the autonomy is just that. It's how far until you shed the load. So that's the point. So the point is that yeah, you're going to have to do that at some point because the battery's going to get fully depleted, and then at that point your load goes off. And as I said, I don't think most people want their loads not to work, a good chunk of the year. What's the point? So I think you want to go with at least a 3-day battery, even at that would be for non-critical load. Hey, if you're lading an HOA sign and it doesn't work in December for a couple of days, I don't think people care. But again, if you've got a telecom site and the tower doesn't work, that's a problem. Or if you've got a railroad and your crossing sign doesn't work, or if you don't know if your trains, if your signals are down, you don't know if your trains, that's a different issue. So they're going to want a higher reliability. In most cases, for most loads, they can get one about 5 days. And again, for critical loads, that's why you go to 7 days or more. They just can't have failure. I mean, and again, it's funny. There's a lot of this comes from the telecommunications world from years ago. AT&T had this thing called the number of nines. And so you mentioned me say 99.9%, 99.99%. Sometimes you want to go out to 99.999%. And for each one of those additional nines, the cost goes up dramatically. So there's a trade-off between cost and reliability. Again, the sweet spot is generally going to be somewhere around 5 days, ideally for cost versus availability. Again, if you need higher availability, you pay a little bit more for it. You have to go to um, a higher autonomy to do that. If you want to save a little bit of money, you can go slightly lower autonomy. But keep in mind, you're going to have less reliability. So it's all kind of a trade-off there.
All right, very good. I see a question from
Hey,
Mike.
Mark,
He asks, go ahead. I'm sorry.
sorry, there's one question I guess I'll pop up that I thought would be good to bring up because it's something to consider when selecting a battery, and that's recyclability, and disposability. It's something we didn't touch upon, but it is something to be aware of in that depending on technology you're looking at dealing with, make sure you understand the implications of disposal at the end of life and recycling at the end of life. Because lithium batteries don't necessarily have a great recycling stream right now. You know, everyone says they can be recycled, but to do so, you're typically paying for it. You know, you take a lead acid battery, easily recyclable. Typically, you actually get a little money for them at the end of life. Just be aware of that when selecting a battery, that you also do have to consider that uh, when deploying a product, uh, what's going to happen when it reaches its end of life. We have to, get rid of it.
Okay, so thanks for that question. Thanks for that answer. I see a question from Doug. Is there a way to determine if you can use a smaller battery if you oversize the PV array?
Sometimes you can, keeping in mind, again, the reason that the battery's oversized is to compensate for days of cloudy weather, inclement weather, um, especially in the wintertime. So you can decrease it and increase the solar array, and your loss to load probability might be still okay a little bit. But again, you're talking about there's a couple. I mean, you're working with a couple of variables at a time, and there is an optimum type of spot for that. You'd have to run a loss to load probability analysis based upon that. Again, I know solar is cheaper than batteries at this point. I understand that. So hey, it's like, hey, if I double the size of my solar array and half the size of my battery, the answer is your loss to load will not drop by half, but it's still going to be less than if you size it correctly. So again, it's there is a trade-off there, and again, you're trying to compensate for cloudy weather or inclement weather. And I mean, as an example, I mean, hey, they're right now on the East Coast, they're getting hit after storm after storm after storm, and if you've got snow on top of your solar array, you're not getting any charge. I know I've gotten my system on several days now has put out nothing at my house. And hey, one day is not going to compensate me for, one day is not going to work when I've got snow piled up there for a couple of days. So just something to keep in mind. Again, you're trying to compensate for bad weather, and no amount of solar is going to compensate for. I'll give you an example. If you're inside the Arctic Circle in Alaska, you can have the biggest solar in the world. It still doesn't work when you don't have any sunlight at all. So again, there's a trade-off to certain things, and you need to do loss low probabilities and an analysis to figure out what would work best or optimize that design um, for that area for that application.
All right, very good. And I see a question from Peter. What are the hazards if my battery shed catches fire, especially with lithium iron phosphate batteries?
Depends on what's near your shed and what's in your shed. I mean, I hate to say it, if you're out in California right now with dry crash, you could create a massive wildfire, or in some other region like that. I don't know. If you're in the woods, again, you could ignite something else. Uh, I have no idea what's around your shed to be able to answer that. But I mean, to some people, they're like, hey, if my shed burns down, I don't care. It's fine. The shed burns down, so be it. Um, I don't know. I mean, if it ignites something else, that could be a problem. So I have no idea what's around the shed.
Steve, you have
Yeah,
any
the
input
biggest
on
thing,
that as far as water reactivity, maybe with if they're trying to put it out with water, or any other thoughts
uh,
about that?
the biggest thing is I think lithium can be extremely hard to put out. You know, from what we're seeing in the codes, it's almost you just let it burn. So the bigger issue is, going back to what Rob talked about, is what else is going to start on fire. And are there code concerns there, and insurance concerns? So, just something to make sure you're aware of, you know, what happens if that does happen.
All right, very
Yeah, and to
good. I
Steve's
think,
point about the insurance, for the first time this year, we saw insurance people involved in the codes. Never seen that before in my entire career, but there are insurance people now involved in the codes because of it. So again, Steve's brought up a few times, but it is true.
Yeah, well, we're starting to see, we talked about this in the codes a while back about even with electric vehicles. We're hearing rumors of, not being able to charge your electric vehicle in your garage. Or if you have a fire, at least you may have problems. Now, I don't know how true that is, but that's certainly some of the rumors we're hearing. So just be aware of that and talk to your insurance company and talk to your code officials so that you're covered if something does happen.
All right, good point. I think we have time for one more question. Do you see any in there? I see one that we have not covered. Can I ask that, or is there something, Steve or Rob, that maybe you see in the questions that you have a preference over? I think there's only a few that we haven't answered. We'll run
I'm
it
not
short
looking at
on
the
time here.
questions right now, but Mark, we do have one last polling question for the audience that we did not
Okay.
get to.
Okay.
I
Let
think. Is
me.
that
You
correct?
know what? Yeah, you're correct. Let me ask this question first, and we'll ask the question. How's that?
Okay.
Try to
Again, we'll
take
kind of
care
be
of
able
this
to end with
quickly.
that question, maybe.
So this question says, let's see, when we talk about cycles, how is that related if the battery is topped off? He says basically, if my standby batteries are rarely used, does the day to night to day uh, charge off my solar count as a daily cycle?
That's correct. And so basically, you're cycling that battery at night, and so basically, you're discharging at night and recharging it toward the day. So that battery is going to be, again, depending on how big that battery is, whether it's a 5-day battery or whatever, can be cycled 20% or less. I mean, again, if you're only trying to get through the night, some days it may only be cycled to 12 to 15%, because again, the sun will handle it for a good chunk of the day. So it's only being used at night and then gets recharged again. So that may only be a 20% cycle or less. But yes, a cycle is from when you've discharged it to when you recharged it.
Yeah, but you have to compare it to the overall capacity. So, if I'm reading between the lines on your application and you're not really using much out of the battery, so yes, it's a cycle, but if you're at, 5 or 10% depth of discharge, you're going to have a lot of cycles available.
Right,
Absolutely.
great.
Yep.
And now I will launch the last polling question. This will be the last question. So this is which are better, lead acid batteries or lithium? So let me launch this. And people can answer this question.
And I have to laugh because I think people are listening because the answer again is coming up mostly
People
it depends.
share the results here.
Uh,
There you go. Yep, most people said it depends, 68%.
yeah.
And then there's quite a few who do favor lead acid that are on this webinar, 27% and 5% lithium. So it depends
Yeah.
who's
And,
on here
and
with the
look,
applications.
let me tell you, lithium has their application. I mean, geez, if I'm in a mobile application, weight's an issue, then definitely lithium is a great option if weight's an issue or something like that. But I mean, if I'm at a stationary UPS, I don't see any advantage to lithium, personally, me. I'm like, I don't need the cycling capabilities of a lithium battery. I could care less about the weight. It's a stationary application. It doesn't matter. So again, I come back to it just depends on your application, what you're trying to do, which is why I always come back to it depends. So I
Right.
think with that, if there are no other questions, I just want to say thank you to everybody. Thank you to Morningstar for putting this together and getting us all together to do this. So thank you to Mark. Thank you to Steve and to also in the background. We've also got Ken over at BAE who's been helping out too. So thank you to Ken also. So thank you to everybody.
Thanks,
Great.
everyone.
I'm going to close things out, and just a reminder that when I close this out, you'll have a browser come up that will let you rate the webinar. So we please ask you to rate the webinar and make any suggestions or final questions. With that said, we're going to close things out. We'll see you next time. Take care.
Thanks, everyone.